Assalamualaikum and good evening. This is our mini project for ENT334 component design, which is our title is improvement on the part of real Excel. Okay, first our group member is Muhammad AIMAN SYAHMI bin SAIFOL ANUAR, and then Muhammad AMIR NAZWAN bin Muhammad NASWARDI, and me Muhammad HAFIZ ISKANDAR bin KAMALBAHRIN, Muhammad SAIRUL bin SHAMSUL ANUAR. Okay, I will do the introduction. Firstly, my name is Muhammad Hafiz Iskandar, matric number 2011110796. Okay, for the introduction, as we know, mostly car have a two axle to rotate the wheel. The larger the vehicle, the more the axle that it has. Okay, the car axle also functions as a successor to the engine rotary power to the drive shaft. In this mini project, we are going to improve some modification on the rear axle car automotive model, which is Morgan Roadster. The Morgan Roadster is a model produced by the Morgan Motor Company and introduced in the 2004. We want to focus more about the rear axle, which is tubular lift axle with high point gear and limited slide. For the problem statement, we have four problem statement, which is four component part. First is gear. The failure of different gear on the damaged ring and pinion, especially on its gear teeth, make a strange noise due to the way of travel in the sharp corner and less durability of its original material. And second is shaft. The typical failure model are summarized, including fracture, corrosion, wear and deformation failure. And the third is boot. A fractured rear axle bolt allows to the rear axle housing to move out of position and resulting in significant noise and vibration. And the last is bearing. The failure of bearing when it fails to meet expected life of performance level, often causing a machine shaft to fail and the system it is a part of it can break down. Okay.
For the objective, we basically have five main objectives. Firstly is to increase the top speed and increase efficiency, and also to increase the durability of the axle of the bevel gear. Secondly is to increase the lifespan of shaft. Thirdly is to increase the durability of the bolt of the axle. Fourthly is to increase the maximum speed and to increase the bearing precision to run at higher speed. And lastly, we compare the parameter between the original part and we improve each component part. This is the overview of component. Firstly, we take the bevel gear, which include the pinion gear and also the ring gear. Secondly, we took the shaft. Thirdly, we took the bolt, and lastly, we took the bearing. For my part, I do the bevel gear component. So basically, bevel gear are the gear where the axes have two shafts that interact together, and two bearing face the gear. So it is often mounted on the 90-degree apart, but can be designed to work at other angle as well. And the pitch surface of bevel gear is a cone, which is known as a pitch cone. So basically, bevel gear is function to transfer the energy from linear to vertical power. So actually, in the car, it is in the differential gear. So I took a bevel gear to draw it. This is the calculation of the original design. We provide all detail in here, start from number of tail until the limit load of gear. Is the calculation for the improvement same method like the original ones, but of course differ in the calculation the data. This is the table comparison. Basically, the differ is number of teeth in the gearing, which for the original we used 39 and for the improvement we used 37, which means we lower the number of teeth, and which means we lower the final drive ratio to make it have a better fuel economy, to increase the top speed, and as well for the roadster car can drive smoothly for the higher speed. And yeah, of course it lower the torque, but it not too much low, and it is still going enough for the roadster car. And yeah, for the power, for the pitch line velocity is still the same, but what I want to focus is for the load of the material. Since we use improvement at the material, we use SAE 1040 compared to 1030 at the original. It improve the load, the amount of load, which means in the improvement is can have a more load on it. This is the original drawing. So I provide all of the angle of view in here. So for the improvement also same as like the original one, but The differ is, like I said earlier, is only the teeth and also the diameter of the ring gear.
So this is the drawing of the shaft. This is the drafting drawing, and this is the 3D drawing. So this is the improvement that we made to the shaft. To improve the original shaft is by using a different material for the shaft. And as the design of the shaft is already perfected to other parts, we can improve the shaft by using better material than the original, which is AISI 1045 to AISI 1050. So the tensile strength of the shaft will be increased from 630 MPa to 690 MPa, while yield strength from 530 MPa to 580 MPa. So this improvement will increase the shaft lifespan and lower the risk of the shaft being damaged. So we also included the comparison table of the shaft specification. So this is the calculation of the shaft and material selection. So what we have here is table A20, which are the common material for shaft production. So the original material is AISI 1045, and the improved material that we have choose is AISI 1050. So the original shaft have tensile strength of 630 MPa and yield strength of 530 MPa, and the improved shaft have tensile strength of 690 MPa and yield strength of 580 MPa. So this is the improvement that we made by using another material for the shaft.
I will continue about the bolt calculation. This here we have calculation of two, which is original bolt and improved bolt. These are parameters that we use to calculate the tensile load, the final value. Okay, first we have size, then property class, minimum tensile strength, diameter, pitch, tensile stress area, and tensile load. The property class we can obtain from the table 811, and the minimum tensile strength we also obtain from the table 811, and the pitch we obtain from the table 81. This calculation that lead to the value of tensile load of the original boat and improved load, which is original boat has a 60.31 kN, and the improved boat has a tensile load of 70 and 75 kN. And this is our comparison of the parameter for the original boat and improved boat. What we improve in this boat is material of the boat. I will speak about the similarity first, which is the size of boat for original and improved boat is remain the same, which is M10, and then the body diameter and the pitch will also the same, which is 10 mm for the diameter and 1.5 mm for the pitch. But the difference is the original book used the material from the property class of 10.9, and the improved book used the material from property class of 12.9, which is lead to the different in tensile strength. For original book, tensile strength is 1040 MPa, and for the improved book, tensile strength is 1240 MPa. This different in tensile strength affect the different in tensile load, which make the improved book has a higher tensile load than original book. That's it. This is our design for the book, for the improved book. We using Katia V5 software. Okay, from there we can see the dimension of the improved book, which more accurately and make us use Katia more easily to extract the dimension and design of the book. Improved book.
First of all, the bearing is a crucial part of the wheel assembly that connects the wheel and the axle. It is a set of metal balls or tapers which is being held together by a metal ring. It enables the wheel to rotate smoothly with a minimum of friction. So for our selection for suitable bearing, we are calculating the static load rating to find which the correct dimension for our system. So for our static load rating system, we are getting about 26.051 kilonewton, and we can see that in table 11.2, the range for our bore is about 35 to 40 millimeter, and then for outer diameter, we are getting about 72 until 80 millimeter range. Next is the improvement for our bearing. First of all, we are using the lubrication method using oil and grease, but these two substances are using in different situations, such as grease being used when the temperature is not over 200 degree Fahrenheit, and then grease being used when the speed is low, and then using for the unusual protection is required from the entrance of perimeter. And then we use the oil when the speeds are high, and then also when the temperature are high, and also when outlet seals are readily employed. And then by using the preloading, we are removing internal clearance between ring and the ball to increase the fatigue life of the bearing. And then by choosing the correct material, such as high purity material, we can get the long last type of bearing. Next is evolution and justification. First, in gear, the increase in the pitch line velocity in improved design will have an increase in the velocity. And then the improved design has a smaller number of teeth compared to the original design. Improved design will have less torque produced, and the smaller number of teeth will lead to the taller gear ratio, means that there will be better fuel mileage and less noise, which make it great in cruising speed on the highway and increase top speed as the car type is roadster. And then in shaft, by changing from old to new design, there will be greatly increase in tensile strength and the strength from 630 megapascal to 690 megapascal. After doing some calculation, we can observe that the increase of tensile and yield strength can also increase the endurance limit, which increase the durability and reduce the chance of failure. For bolt, we can see that both tensile strength and the tensile load of the improved design is 17% higher than the original design. So based on this, we can conclude that the improved design can be more stable compared to original design. And for our bearing, the improved bearing performance is by adding the lubricant. We can see that there are types of lubricants such as grease and oil. Bearing lubrication is very important for preserving the performance lifespan of rolling element bearing. It helps to separate moving parts relative to one another, such as balls and rollers, to prevent wear and tear friction. And then we can also using the preloading methods, and also by choosing the pure material.
So the discussion in completing the mini project, we improve four components in the Morgan Roadster model car system rear axle: the gear, shaft, bearing, and bolt. While looking for ways to improve the efficiency of the rear axle system, we conduct extensive research to find the appropriate material and dimension to improve the rear axle system. We changed the gear tooth count from 39 to 37, and also improving the material of steel from SAE 1020 to SAE 1040. The metal for the shaft is changed from AISI number 1045 to AISI 1050. The original bolt use material from property class 10.9 for the bolt, while the improved bolt use material from property class 12.9. Finally, for the bearing, the use of lubrication to provide a lubricant film between the sliding and rolling surfaces and prevent corrosion of the bearing surfaces. That's all for discussion.
The conclusion, we basically have achieved 5 of the main objective. We may exchange for the element like gear, shaft, bearing and also bolt, and we've been able that the decision and analysis we make can improve the efficiency, performance and also the durability of components. So as a result of the project, we able to complete it. We able to grow into more responsible individuals since we can do the given task, and I think for the knowledge that we gain in this mini project, we can use it for the future. So that's it. Thank you.